Good day, everyone. Welcome to this webinar. The title of this webinar is Monitoring and Evaluation Frameworks for Assessing the Impacts of Climate Change Interventions. This is the fifth webinar in a series of 6 for the SDGP facility. This webinar will be recorded. My name is Maxime IJsselin. I'm a senior expert in nature-based solutions at IUCN Netherlands. IUCN is the largest global network of organizations working in the field of nature conservation and sustainable use of natural resources. Today, I'm your moderator and I'm the timekeeper of this webinar. We have great speakers from the Netherlands Enterprise Agency, Renature, Aidenvironment, and Wageningen University and Research. The goal of this webinar is to share knowledge on monitoring and evaluation in the light of climate change, and we dive into both theory and practice of both qualitative and data-driven monitoring and evaluation methods. So concerning the webinar structure, the first webinar explores the concept of learning-oriented monitoring. The second presentation presents a case with participatory monitoring of a climate-resilient rice farm in Indonesia. The third presentation dives into how to capture the added value of agroforestry, and the fourth and final presentation gives insight in a land simulation platform for impact assessments. We invite you to post your questions into the chat. That's very important because one or two can be answered after each presentation during the webinar. Others can be answered afterwards by contacting the speakers directly. Some simple housekeeping rules. Please mute your microphone during the webinar, rename yourself, and include your name, your organization in the name. Please introduce yourself also in the chat so we can create a living community. This webinar has been made possible by the Netherlands Enterprise Agency and with technical support from Ben Sonneveld from the Vrije Universiteit Amsterdam, Renature, and IUCN Netherlands. I hereby would like to invite Ms. Amarens Velperlaan, Senior Project Advisor, Food Security and Cacao, for a formal welcome on behalf of the Netherlands Enterprise Agency.
Good morning, everyone, and thank you, Maxime, for introducing me. My name is indeed Amarens Velperlaan, and I work with the Food Security and Land team at RVO. On behalf of RVO, a very warm welcome. And yes, I'm very happy to see so many of you on the call from all over the world. It's nice to have such a great community interested in monitoring and evaluation. Indeed, today's webinar is on monitoring and evaluation in a changing environmental setting. And as Maxime already mentioned, we have various speakers. The first is my very dear colleague, Veerle Lambert. She will talk about learning-oriented monitoring. And this approach is new to RVO. And within this approach, we emphasize learning and adapting in real time. Maxime also mentioned we have 3 case studies after this presentation from Indonesia, Philippines, and Madagascar. And we have speakers. The first one will be Uma from Indonesia. She will talk about how to integrate traditional knowledge into M&E. And the second is Lysanne from Aidenvironment. She has developed a separate tool for agroforestry to capture the real impact, the added value of agroforestry. And then we'll finish with 2 speakers from Wageningen University. And well, has also been mentioned by Maxime, they will talk about the land simulation platform, and it helps to simulate the impact of interventions on the environment and food security. Well, for now, I would say enjoy the webinar. It's fully packed with lots of information and interesting insights. I hope you will learn a lot from it, and it will bring or inspire you in your work. So for now, I'll hand over the floor to my colleague, Veerle Lambert. Thank you.
Yes, thank you, Amarens, and thank you everyone for being here. I saw some familiar organizations going past in the chat, so nice to see you all. My name is Veerle Lambert. I work at RVO, the Netherlands Enterprise Agency, and I am a PMEL advisor, so planning, monitoring, evaluation, and learning. And today I will talk a little bit about learning-oriented monitoring, which the name already gives away. Is about monitoring with a focus on learning. And this is something that we are trying to do within RVO, within different programs. And I'm going to tell a little bit about why we are doing this, when it is helpful to implement this way of monitoring, and what it looks like. And I'll try to give a few examples, but also very open for questions afterwards. Next slide, maybe. Yes. So really short about RVO. For those who don't know, we are an implementing organization of the Dutch government. And I work for the International Cooperation Department, and we are working on different themes. These are renewable energy, water security, responsible production, private sector development, and food security. And we do this by implementing programs together with knowledge institutes, civil society organizations, companies, and governments. And we are trying to contribute to a whole lot of things, but a few of them are access to renewable energy, accelerating the green energy transitions, and all the other ones that are on the slide. And well, as you can see, these are quite big challenges. And you're all working on climate change, climate action. These are also quite big challenges. And as you can, well, probably relate, these are quite difficult to tackle, and they don't, well, one simple intervention doesn't do the job. So next slide, please. Yeah, this picture illustrates that a little bit. We are actually working on trying to change difficult systems, and it is well, this picture shows it is quite difficult to do that because we can only see part of the problem, which is in this case the tree above the ground, or you have similar pictures with the top of the iceberg. And what you can see with just a single linear approach, you won't do the job, because there is actually this complex reality under the ground, the root causes of a system that you need to address in your approach. Next, please. And that doesn't only have an effect on the way you are implementing your program. Oh, previous, please. Yes. Doesn't only have an influence on the way you implement your program, but also on the way you can do your PMEL approach or your MEL approach. Whereas in the more traditional sense, often monitoring was used for accountability, to prove that what we did was good, or hopefully. And now we can see there's a bit of a shift towards more learning. What are we doing? Are we doing the right things to reach the objectives that we have? And is the focus also more on improving our program than on proving that we are doing the right thing? But you can see it's a tightrope. There is a little balance between the two, because when I say we are focusing on learning, doesn't mean that we're not still also looking at accountability and also the more traditional way of monitoring. Next, please. Yes, so what we do is learning-oriented monitoring. It is not a specific method, but it is more an approach towards monitoring. And then we took elements also from reflexive monitoring and action, maybe familiar with some of you. But in a sense, it is a proactive way of monitoring that encourages proactive problem solving. So you're continuously like discussing with different stakeholders, what are we doing? And you really try to take into account the whole context. And you can do this, for example, by developing learning questions that you're trying to answer during the implementation. And what is very important is that it turns learnings or lessons that you take into action. So you don't just implement this to collect a lot of lessons and write them down, but the idea is that you really change it into actions. Next, please. Yeah, a little short recap of why and when do you use learning-oriented monitoring, or would it be helpful to implement some of the elements of learning-oriented monitoring is, yes, is when you work on system change or transitions. Well, many of you are working on climate change related programs, so often that is probably the case. Also, the goal of the project is known, but how you're exactly going to get there is often unknown, and there is a space within the project or program to adjust and adapt. And also, the context in which you're working is complex and not linear. And the picture shows also a little bit that, for example, you're working in a simple context is like baking a cake. You know, you have to follow the recipe. If you follow the steps correctly, you'll end up with a cake. But if you're in a more complex reality, you can think of raising a child. There is no right or wrong. Well, there's a lot of outside factors that influence the outcome, and experience helps, but it doesn't guarantee success. So that is maybe a little bit of a helpful way to think about in what kind of context is my program at the moment. Next, please. So as Amarens also said, we have been implementing this within RVO for a few years now. And we found a few conditions that you really need to have in place to do this in a good way. First of all, there needs to be a learning culture. So people need to be open towards like reflecting on what they're doing, also be open about what is not going well. So a safe space is also very important. People need to feel free to share failures and not be, reprimanded for that, but that is seen as learning. It helps if there's a mandate to do this, so that you also have the space to adapt when it's needed, so that you really can make those changes. And also you need to have the time and capacity to do it. I'd like to give a little side note here, because I feel like I found that learning-oriented monitoring is also something that you can really integrate in things that you're doing already. So it shouldn't add too much extra time, but sometimes that needs a little bit of a mind shift as well. Next, please. Yeah, you can click through the animations, because this is a model. You don't really have to go into it. It is basically a variation of a lot of PML cycles that are probably familiar. But what I'd like to address here is that it is really about the cycle of reflecting, learning, and adapting. So that is very important. And you can see an inner and an outer circle here that shows that you do this on different levels. And I'll come back to that a little bit later. Little things that we do within this cycle is at the beginning, at the ambitions stage, we help developing with intervention strategies to define the impact goal and the outcomes that we would like to receive. And this could be a TOC or an intervention logic or an intervention strategy. And then mostly what we do is have reflection sessions or learning sessions where we reflect on those learning questions and barriers and opportunities that we run into while implementing the program. And then the most important step, or a very important step, is that we adapt where needed. So we really do that while implementing the program. Next, please. This shows a little bit that we are learning on different levels. It's very helpful to take this into account, so that you don't just stay reflecting on this first loop, which is mostly about the activity. So it is really about, are we doing the things that we do in the right way, which is helpful. But if you really want to learn and adapt your program towards the impact goals that you have, it's good to also go a little bit deeper. So that's the double loop and even the triple loop. That's where you're really looking at the strategy that you have, the program logic. Is that still correct? Do we need to make adjustments in the strategy? Or do we even need to make adjustments in our mission or vision? Does our strategy still match with the context of the system we are working in? So it is really that reminder that you sometimes have to really go a little bit deeper than just, are we still doing the right things? Next, please. You can skip this one. Yes. As I said, the reflection sessions or learning sessions, doesn't really matter what you call them. Those are basically the main, or one of the main parts of what we do within our programs. And it is really a way to bring together different stakeholders to reflect on the implementation of the program, and we have some different flavors in that, if you will. So first we have the informal learning sessions. Those are often more internal sessions with, for example, for us, that would be RVO or the embassies that we work with. And that is mostly focused on that single loop. So are we still doing the activities correctly? Should we adjust a little bit here and there? You can do them a little bit more often, and you can often combine them with calls that you have anyway. Then you also can do a Zoom-in session where you for example, look into one specific learning question, and then you can go a little bit deeper. And often you invite different experts, different people to this session, or implementing partners. And then also you can do a yearly reflection session. And this is often a time where you also go back to the strategy and see, are we still on board with the strategy we had, or do we need to make changes in that? Maybe one small example of one of those learning sessions and why it could be helpful to do a learning session maybe on top of the monitoring that you already do is for an agroforestry project that was done in Sri Lanka. There was this assumption that there was a pilot plot with agroforestry, and the assumption was that less fertilizer would be used there. But after the data collection, it was found that there was actually more fertilizer used there. So, well, based on this data, you could maybe conclude, oh, the pilot was not that successful. But it was the MEL approach didn't stop there. There was a learning session afterwards where not just the farmers and the program people were involved, but also some experts and a professor, and it was this finding was discussed, which could also be a little bit scary. So that safe space is important. And it was, well, discussed that it is actually not that weird that there was more fertilizer used, because there were new plants, and well, in the beginning years, maybe it was okay to use a little bit more. So the conclusion was wasn't the pilot has failed, but it was, okay, we need to monitor this better to see how much fertilizer is actually used, and see if it got less over the years. But also they identified the need for a bit more training on the use of fertilizer, so they could really make that adaptation while implementing the program to implement this training as well. And here you can see, by not just focusing on the data, but also including different types of stakeholders and discuss this in an open space, you could steer the program towards a better direction than coming to conclusions too early. So that's a short example of how and why a learning session could be beneficial. Next slide, please. Yeah, a learning session could look in many different ways. So it can be very traditional, sticking post-its to a flip over, always comes up with new insights, I find. It can be a bit bigger, so you can see in the photo on the right bottom that there is many stakeholders around the table, and it's really time for reflection and discussion. You can also incorporate field visits, so you take those learning questions into account while visiting a site and then reflect on them later. But
one more minute.
Perfect. What we also do a lot is that we have them online. So in the bottom, you can see a screenshot of a Miro board. It's a tool we often use. It's basically stick and post-its, but then virtually. And that is also a very handy tool to do this online, because you can't always get together in the context that we work in. Next slide, please. Yeah, well, these are the last two slides. We work a lot with learning sessions, but there are some different tools that we also use. So for example, it's the dynamic learning agenda, maybe familiar to you. This is a way to organize the learning questions that come up during implementation and to keep a good overview of them. So what are the learning questions we have? What is their priority? What is the follow-up action? Who's responsible? So just to create that overview. And the next slide, we also have the tool, the logbook of change, where you can write down any observations or lessons that come up while just implementing the program, and they can be used as input for reflection sessions later or to analyze over time. That was it. Next slide, which is the question slide, I guess. Yes.
Great, Veerle, super, so interesting. Thank you very much for this, for the explanation of what learning-oriented monitoring means. Could you perhaps elaborate a bit more on how it relates to more traditional forms of monitoring?
Yes, sure. I really would like to say it is not a replacement of traditional monitoring. So it could be seen as an add-on, but it is not necessarily extra, but you can really integrate them together. So, for example, quantitative information that you collect can be input for those learning sessions. For example, as I explained in the example I have. So I don't want to say quantitative indicators are bad. You don't need them, because that's not the case at all. But it would be very good to combine the two types of information together. So that is a little bit how it would relate ideally.
Very good. And can you tell a bit more on what type of projects are suitable for learning-oriented monitoring, and in what cases should you not apply this approach?
Yeah, I think it is definitely if you're working in a complex system or trying to change a system in which you don't exactly know how you are going to get there. So you have an idea, but there are still some big questions. Those could be learning questions that you answer along the way, and that would really help you to define the way you are going to reach that goal. And what is very important with it is also that there is that room to adapt. So if you have maybe a different mandate that is very strict, or protocols that you have to stick to, then it is not very helpful to do this, because it could be even more frustrating. But if there is room to change what you're doing, then it would be very interesting.
Okay. Thank you very much, Veerle. Thank you for your presentation. So the next speaker, I invite Oma Khumairoh, who is partnering with Renature for their RISE project on Bali, Indonesia. She will give you insights on the participatory monitoring and evaluation activities in regenerative rice cultivation systems. So, Uma, the floor is yours.
Thank you, Maxim. Good morning, everyone. I'm Uma Khumairoh from Brawijaya University in Indonesia, together with Renature and Astung Karawe. We work on transitioning regenerative rice in Bali using complex rice system cultivation method. And thanks to the committee for the invitation to share our experience on the monitoring and evaluation of this project. Could you please move to the next? Yeah, I will start with the background why this project is important. First, because rice is the main staple food of more than half of world population, mainly 90% living in Asia. But at the same time, rice is often criticized as significant contributors to climate change due to the farmer habit in burning rice straw and then flooding rice field that create anaerobic condition and activating methanogenic bacteria that release methane. And move to the next, please. But at the same time, rice is also a very susceptible commodity to climate change. For example, with prolonged wet season, it's very favorable condition for pest and disease to develop. And but during rainy season, many pesticide is not effective because washed off by the rain. And rice plant also, a lot of rice plant damaged by rice when it by rain when it is fall very heavy, and then it's affect on the quality and quantity of rice grain. And during the dry season, it's also create migration of pests and diseases. And the heat from the during the dry season also can increase pH of the water. And when farmer mix the water with pesticide, it can degrade active ingredient of pesticide. So then it will be not effective anymore to manage pests and diseases. And again, rice yield become drop dramatically because of these pests and diseases. Next, please. Yeah, so then we come with a nature-based solution. We call it a complex rice system that integrate plants, animal, and management in rice system to enhance ecological processes. And so, for example, we use azolla, fish, duck, and border plant. And duck and fish in this system, maybe we can also move to the next slide. Yeah, you can also click the animation there. Yeah, if we grow rice, then it's also invite pests and weeds. But then when we have fish and duck can eat these weeds and pests. And then the azolla itself also, this is a nitrogen fixing plant that provide nitrogen for the plant in the system. This also contain a lot of protein that can be used as feed for fish and ducks, and then and thus reduce the feed supply from outside the system. And yeah, we also have border plants there on the rice band with many types of crop that invite natural enemies as a double protection to rice there. And altogether, duck meat, egg, fish, and border crop, they also provide diverse income for farmers. And yeah, please next. Next slide. Yeah, this is some example of our complex rice system design. It's not to be like a whole component inside, but it depends on the location, on the situation. So farmers can maybe only mix rice with fish, rice with duck, rice with legume, and rice with other crop. Or yeah, if they want, they also can mix all together. The next one. And yeah, this some example of our farmers doing this complex rice system. On top, they even integrate rice with some trees, mostly food trees. And under the below picture, it was in with this complex rice system, many women also can involve in rice farming because they love to grow this vegetable and then sell it as for while waiting the harvest of rice. Next one, please. Yeah. So yeah, now we come to to our case study in Bali. The project was implemented using farmer field school approach that involved participatory experiment. So all farmers there, they have their own land, and then they implemented this complex rice system in their field. and we meet like every 3 weeks to learn together in a capacity building session. And there is like a contract with farmers to how do you call it, to build the commitment, including that they were not allowed to burn rice straw, and then they were not allowed to use a pesticide, herbicide. But then this Astun Karawe, they bought the rice with a higher price from farmers. And then during the meeting, in the morning time, farmers did monitoring to their rice field for the pest, the weed, and the development of the ducks there. And then after doing measurement, they collect the data and then did a presentation, and other farmers also give feedback, and then we plan for the next meeting. And this actually almost the same as the monitoring process, same as previous speaker about how do you call it, learning cycle, where first they describe and then they try to explore what happened there and then try to find solution and then doing design to improve the design, and then they come again what happened with current design. And that's why this system cannot be done only one cropping cycle, so we did it in at least 2 cropping cycle at the beginning. And we started with 14 farmers, but now it's already more than 200 farmers applying this complex rice system in Bali. Next, please. Yeah, so this is some curriculum for our capacity building, where we meet every 3 weeks after measurement. We discuss about nutrient management, on the integration, how to properly integrate duck, fish, legume, and other crop in the rice, and then how to manage weed and pest effectively, and several rice planting method. Next, please. And then by the end of the season, so rice was grown like almost 4 months, and then during the harvesting, farmers come together and then bring their soil, their straw, their also rice, and then we evaluate together, we monitor together. So that's why we call this as a participatory evaluation and monitoring. Next, please. Yeah. Based on this monitoring, so it's from farmers itself. They measure what happened on their farm, and then we collect the data together, and then they present it. So based on the agro biodiversity, we found that complex rice system, they they have more. They were diverse than the conventional system in terms of species diversity. There's like duck, legumes, etc. Yeah, next please. And unfortunately during the first cropping cycle, it was like there was like outbreak on stem borer. So not only complex rice system, but also all of rice surrounding the area was attacked by stem borer. But many complex rice system farm can escape from this incident. Next, please. Yeah, so even they did not apply pesticide, their rice yield still good. As we also send the sample from the rice to be to send to laboratorium to test if there are some residue of harmful pesticide, and all of sample from farmers, there's no any chemical detected on the in the rice. Yeah, next. And yeah, in one cropping cycle, we found that 50% farmers, even during this outbreak, pest outbreak, they experience increasing of rice yield, although 50% also, yeah, there was reduction in rice yield compared to previous cropping season. Yeah, next. Yeah, and then together with farmers, we also calculated the economic aspect where, yeah, although like plowing cost, seedling, planting was higher in complex rice system, but then because the ducks and fish, they effectively control wheat and pests, so then they did not need to do hand weeding. Hand weeding, it's quite expensive. Yeah, it's around 50% of cost production in rice because of labor. Yeah, the labor cost is very high. And then for the we can see there, if the price of rice both like higher than conventional, then the profitable received by complex rice system is like more than 80%, 89% higher than conventional. But then if the rice was like sold the same as conventional, then the price only 31 to 38% higher than conventional, but still it's higher, the profitable. Next, please. Yeah, and we also did a soil health assessment. So here we combine both laboratorium and also visual assessment of the soil. Based on the laboratory analysis, you can see there that, yeah, in complex rice system, even in we still started in the first cropping cycle, except for the nitrogen, the NP, K and the P, K and C was higher than in conventional, but still lower than organic one, because the organic already started 3 years before complex rice system. And the microbes, the organism there, the soil organism is like 23% higher than conventional, and 23 times higher than in conventional, and 6 times higher than in organic. And for the soil assessment, yeah, it's we need like a bit improvement on how we deliver this to farmer, because it's sometimes it's not really how do you call it, that's why we also have this laboratory, because somehow the result maybe not exactly as in the result of laboratory, because like the analysis only based on the odor and then color and etc.
1 minute.
Yeah, next please. Yeah. So yeah, maybe I can skip this one, but I just want to say here that within one cropping cycle, the carbon also increase, and then this because farmer really did not burn the straw, and then the flooding period also lower because some farmers did rotation there. Next, please. Yeah, this is other. Yeah. Yeah, it's what we are not getting here is the involvement of women, that there's no significant positive effect on this, but it can be improved for the next. Yeah, so finally, we can conclude that complex rice system can provide many ecosystem services here. To mitigate as a solution to mitigate climate changes. And even now we try to use other crop as well. And yeah, this also provide a large potential for synergies, sustainability production, and to make it more resilient to climate change. But yeah, restoration of traditional knowledge is important to be integrated with a scientific approach to reduce monitoring and evaluation costs. Because if we only use laboratorium analysis, then the price is quite expensive. And yeah, we still need to work on this traditional knowledge. Yeah, thank you. That's from me.
Thank you very much, Uma, for your interesting presentation. I see one question in the chat. It's a new question. It's a bit long. Irene, could you place your question? Could you explain your question shortly?
Oh yeah.
Okay, thank you. Salam kenal Ibu Uma. I'm also from Indonesia. Just want to know about the method that you already explained. Actually, we know that in Indonesia, mostly for the field rice, we use the pesticide. So just want to know, how do you select the location as a model? And then because if we see from the, like a water set or the water, it will be a flow from the upstream to downstream. Although we explain about or we introduce this model, it still contain the pesticide. Just want to know about that. Thank you.
Thank you, Bu Irene. Yeah, it's a case in many rice fields, yeah, because the water is recycled from one field to other field. So then it's not possible to really how do you call it? Even they are organic, they still can get contamination from other field who really that really did not who, that use this pesticide, yeah. But first, the product is not labeled as organic here. So the purpose here is just we started to make farmer aware that actually pesticide was really not working during especially in climate change, yeah, because many barrier on that. And second, different area had different condition, biophysical condition. In Bali, in this project, first because they are not certified organic, they just said that this is a healthy rice, so they give like description on their production. So then consumer also do not really focus on this label, but at least they know that the rice is not using pesticide and other agrochemical, and they start also to grow azolla there. So they have a certain like pond to as a filter to go to the rice field. And this also applied for other, because complex rice system now it's implemented also in mostly in East Java, and also we did this in West Sumatra as well. So yeah, it depends on the condition, but the learning here is not really on the organic certification, but just to show the farmers that sometimes farmers just feel itchy to spray, even no pesticide, they itchy to spray pesticide to rice because they really used to with systematically pest control.
Yeah, Uma, thank you very much. There's one other question by Luuk. We've 1 minute left. Let's go. Luuk, could you explain your question?
Yeah, sure. I just wondered, so you frame it as important for climate change mitigation. I wonder if farmers are also experiencing problems with changing climate and whether this system helps them in that respect.
Thank you for the question. Actually, farmers already started aware of this climate change, and farmers in my area, they even have like a gathering to discuss about this. Yeah, they start to try to recollect their indigenous knowledge that, okay, for example, when some plants already start flowering, it means that it will be a long dry season. It will be like this. And this all indigenous knowledge already gone. Yeah, but nowadays, because for example, now it should be not rainy every day, but now it's already rainy every day. And we already had like a failure in rice harvesting 2 times because of this rainy season. And yeah, at least now they're already starting aware of the situation.
Thank you very much, Uma, for your wonderful presentation. I see one more question, but perhaps you can answer it in the chat yourself, Uma, because we need to continue to our next speaker, Lysanne Vergroesen. She is working for Aidenvironment on SDGP projects, assessing landscape level impact using the agroforestry monitoring tool. With an, as she will explain, an example in a landscape in the Philippines. Lysanne, the floor is yours.
Yes, thank you very much, Maxime, and good morning, everyone. Thank you very much. Yes, I will share some findings, and I will take you on board on our learning journey and how we ended up with the agroforestry monitoring tool. And next, please. Yes, so my name is Lysanne Vergroesen. I work for Aidenvironment, and Aidenvironment is an organization that works on sustainable solution and sustainable landscape management solutions. We work both on the implementation of large-scale programs as well as on the knowledge development and evidence generation in terms of shorter-term assignments. I have been involved in our sustainable landscape management programs over the past years, and I will also draw from these projects in the presentation. So specifically for RVO, we have been involved in the implementation of the Going Bananas project in the Philippines, a project that is very much aimed at promoting an organic banana system, originally instead of monocropping maize. We've also been involved in the Sugar and Steam project in Indonesia. This project is implemented together with Elliott Green and Van Hollarenstein as our partners, and it's aimed at creating a more climate resilient coconut sugar production system for organic coconut sugar. And the third example of the RVO funded project that I will draw examples for today is the ARVSA project. This is a project that builds on a previous work that we have done in the east of Uganda in terms of coffee production with a lot of coffee farmers, and is fully focused on improving nutrition and food security. So basically working in the same area, but moving from coffee to food crops. So that's in very, very brief. Next. For now, I will draw from an example from the Going Bananas project. Going Bananas is a project that is implemented together with our partners at Bern University and Tree Life and University of Southern Mindanao in Mindanao, Philippines. As you can see on the picture on the right bottom, this is an area that has very steep slopes that in which farmers are confronted with the effects of climate change a lot in terms of precipitation. But also in this area, in the past, the production of maize for animal fodder has been promoted a lot by government. And yeah, so basically a lot of farmers are growing maize, but with a lot of pesticides, which is leading to, well, extreme rates of erosion, but also we see that the yields are going down very quickly year after year. So that's the context where we started implementing this project. So the project originally aimed to shift towards an organic banana growing system for these farmers. However, halfway, we already learned that depending only on the banana market would not be the best strategy. So we shifted more towards diversified agroforestry system, combining both food crops with cash crops, so including banana, coconut, fruit trees, but also food crops and vegetables. So this is a heavily degraded landscape, quite complex, as you can see on the bottom. This is where with A-frame contours are being drawn, and where already these contour lines are being implemented in the middle picture. So what we did is we worked with 2,000 farmers to basically facilitate that transition towards a more climate resilient system. Yeah, and in that process, several questions came up that I'm happy to share with you. So first of all, I think what every program implementation organization wonders is, of course, when are you actually doing a good job? So beforehand, you might make a plan of what you're actually going to do. So for example, I talked about only bananas, but halfway we decided, okay, this is not a structural. The banana market kind of collapsed. So at that point, we decided to move for a more diversified system. So yeah, when are you actually doing a good job? I think from an environmental perspective, I think the case can be quite easily made that if you're moving from growing monocropping maize on steep hills with a lot of chemicals towards a diversified agroforestry system, that the implementation of that system is an improvement. Yes. However, I think there are a lot of other things that we needed to take into account that we also learned from in the process. So how does the traditional system towards an agroforestry system, how does it actually impact farmers also in terms of, for example, the farm business case? So maybe you compare, or at the beginning we compared a full-fledged banana system to the original maize system, and that was a very easy business case to justify the transition. However, halfway we noticed that there were a lot of complications there, because so banana did not really yield the price that we hoped for, but also we saw that in the transition process, that means that you're already cutting and you're already missing several harvests in terms of maize, which can be harvested 3 times a year, while moving to a crop that will only be harvested after a while and then once a year. So I think these are all things that we noticed and started monitoring. So the question is, do we monitor at impact level or at implementation level? And what is also realistic in terms of a project timeline? Next slide. Yes. So, and how can we actually show meaningful impact? So, for example, look at most of the times when you're working in different projects, different funders, there are already some high-level indicators that you're looking at, such as, for example, at least 2 interventions per hectare make a farmland resilient to shocks or more climate resilient. Yeah, that's of course a very good indicator, but yeah, looking at, for example, on the bottom left, you see a cover crop being applied, and in the center picture, you see a trench. But what if a farmer, or what if someone has a little bit of cover crops in one area and has a very nice trench of 2 meters in another area of the farm? Can you actually say that that farm is regenerated or more climate resilient? Well, we feel no, even though we might sometimes report as an organization or in the higher level framework, we could say yes. But for us, I think that was something that did not really click. So we felt, okay, we need to think this through a bit more in depth. So, okay, if you don't look at the number of interventions that is there, can you look at the percentage of interventions that has been taken up? Well, you could, but then you're still not sure about the scale or the percentage of land of a farm that is actually covered with interventions. That's doable, but also quite difficult to monitor, quite intensive at least. Can you look at the impact per intervention? So, for example, implementing everything really well on a pilot site and doing very in-depth monitoring, and then after that extrapolating that to the wider context? Or should we look at the landscape level indicators and then, for example, make sure that we also capture impacts that are a little bit beyond the direct project scope? So, for example, on the right bottom, you see in Mount Elgin, a biodigester that is, on the one hand, it ferments cow dung. On the one hand, you get a bioslurry out of it that is applied on some elements of the farm, most of the times the most well-earning cash crops, let's say. And on the other hand, it also leads to clean cooking, reducing deforestation. But that's not deforestation directly on the plot. That is deforestation that is often of nearby forested resources. So, yeah, all of these things led us to the conclusion that we needed monitoring, that we need monitoring from a more integrated perspective, integrating also the plot within the larger landscape. Next. So yes, what is a resilient and restored landscape? Yeah, you can see here the pilot site designs from a water management perspective, also placing the pilot site in the wider catchment area to see, okay, what would be the ideal implementation and how can we monitor that? With this question, I think we moved also to RVO because and we got into some interesting dialogues, and at the same time we approached several other organizations that are implementing agroforestry projects and who we found that are struggling or dealing with the same types of dilemmas and questions in this monitoring journey, let's say. So I think there the idea of an agroforestry monitoring tool came up, basically to make a decision from a project perspective, but also from a funder perspective on, okay, how can you monitor this in a meaningful way? So moving away from only saying, okay, 2 interventions on a hectare is regenerated, but really looking at it in a more in-depth, integrated, holistic way, adjusted to the project context. Next. So yes, was originally aimed at capturing the added value of an agroforestry system on top of a more traditional monocropping farming system, but also looking beyond plot lines. The monitoring tool was designed for RVO to capture this impact, and it helps in supporting how to monitor a meaningful change in agroforestry monitoring projects. So things that are often constraining are, for example, the budget of a project. So I think these are the 5 components that have been taken into account and that this tool takes into account. So what is the total budget of a project and what is the budget that can be allocated to this monitoring? What phase of the project? Oftentimes you would like to start, of course, before a project already starts. In reality, that's never possible because as a project implementation organization, you will know that that's not how the system works. Also, you learn, as Veerle says, halfway, most of the times, which things are really important to monitor. And those are not always the things that you imagined at the very start. So which phase of the project are you? Is there pre-post possible, or are you already halfway? Then you need to come up with a different strategy. The capacity in terms of, do you have a lot of manpower on the ground to collect a lot of data, or is there less possible there? What are the costs of the actual monitoring methods, and also what are the skills that you have? So do you have very smart GIS people in-house? Then you would choose to use different types of methods than if you don't. Next. So yes, the idea is to look at it from a holistic perspective, from an environmental climate perspective, economic and socio-cultural. Maybe I skip. Next. Yeah, so what did we do? We started building a database. This is a very early on shot, but it's a database that we expanded with all monitoring techniques categorized per group, per main indicator, in this case tailored to the RVO head level indicators, but can of course also be used in a broader sense and adjusted, aimed at selecting the feasible, efficient and appropriate monitoring tools for a specific project to help an organization or to help RVO in basically deciding which tools should be used to measure meaningful change of an agroforestry system. Next. Yes, this is a small demonstration of, this is a very, let's say, rough prototype, but I'm already happy to share with you. The idea is that this tool can help you can create basically a project, indicate what the impact areas are, and these ones are very much tailored to the RVO indicators, but it can also be, the idea is to also adjust it, and we already have a version that is a bit broader. Per impact area, you can select the sub-areas that you're interested in. You can, for example, get clarity on what these areas mean. You can see which phase of the project are you, what is the budget, what is the level of expertise that you have. And based on that, the tool will share with you the proposed methods and the proposed way forward. So what do you get out of it? For now, that's a report basically on, okay, which methods are there, which ones are good for you to use in your project, and which ones are not. I think you get the idea here. So it's very low tech, like VSA, visual soil assessment, up to very high tech assessment methods as well. Next. Yes, so where are we now? We developed a prototype and we're testing it in practice before. Of course, you always need to test things into practice yourself before recommending to others. So we started to do that more broadly in the Green Future Farming program in Uganda. So testing basically all of these methods, making sure that we come with a dashboard presenting the results at the end. Next. Yeah, so what is next? Basically, we are now testing and improving this tool in a wide range of contexts, different countries, also different types of projects, reforestation, agroforestry, and taking into account different capacities of organizations that have a very broad technical capacity up to organizations that need more support in that. We're also looking at adding components beyond the SDGP indicators, such as living income, child labor, etc., so that we can have a more detailed and tailored approach, which also includes sampling strategies and the guidelines on how all these findings can be best integrated. Next, last one. Yes, so we are further developing this, but I'm already very happy that I could share with you some of the dilemmas that led us to developing this tool. We are currently working together with quite some other organizations to make a complete tailor-made package for these organizations, and not only a tool, so moving from a tool that can help in the decision-making on the type of monitoring to really supporting with the full-fledged monitoring package. So thank you very much for that. Next. And I think we're at the questions. Thank you, Maxime.
Thank you very much, Lysanne. Very interesting tool. And there are also a lot of questions in the chat. So I would like to give Dedi the floor to shortly summarize the question.
Thank you, Maxime.
Please go ahead.
All right. I'd like to know from all the presenters. Usually when we have completed our projects in certain places, after we have completed all the stages for implementing exit strategy or phasing out strategy, then we also like to know the impacts, right? After we left the intervention area or specific location. So I'd like to know what is your most recommended strategy to monitor the sustainability of your intervention results in addressing the climate change impacts at community or village level or at landscape or seascape level. How do we know that the results of our work are long-lasting and sufficient to help all the right holders as well as the stakeholders on the ground to, maintain their level of, let's say, climate resilience or their ability to implement effective climate adaptation practices or any other forms of locally shaped nature-based solutions. That's it, Maxime. Thank you.
Thank you. Would you like to respond, Lysanne?
Yeah, I can already share my response from my perspective, but I'm also interested what the other speakers would have to say to this question, maybe for the Q&A at the end. But yeah, Dedi, thank you very much for that question. I think it's a very relevant question and a really important one. And to be super honest with you, it is one that we are also struggling with ourselves a lot of the times. And one of the reasons why this is a challenge is that oftentimes a lot of the landscape indicators, you will start seeing the results of those after a year, 2 years, 3 years. As I said, for example, in this Going Bananas project that I used as an example, we were dealing with COVID at the start. We had to deal with changing the cropping system halfway. So in the end, in maybe the second, third year, we were really sure what the interventions would be and also how to best monitor that to make sure that we could capture the full scale impact, let's say. So the easy, but this is not the answer you're looking for, but the honest answer is that sometimes it is quite challenging. So impacts from a GIS perspective, yes, they can be monitored afterwards as well. But impacts on the ground, that really depends on the presence that you have and the long-term availability of a capacity that you have. So for example, one nice example is the Harvesting Health project that I was talking about that is building on to the project of Green Future Farming, the coffee project in East Uganda. That does allow us to have a more longer term monitoring process. In this area, we have quite a big office, we have quite a long-term presence, and therefore, it does allow us to really build from one onto the next and to capture long-term landscape impacts, so 5-year plus. And that does give us a lot of added value, and it does give us a lot of insights that we hope for. So yeah, let's say from my very practical point, I think from a GIS perspective, there is quite a bit that you can do in terms of longer term monitoring. But from all the underground indicators, of course, you can only assess that if you actually have a permanent presence in the area. So that is my very honest answer.
Thank you very much, Lysanne. Great, thank you. There are also more questions. Perhaps, Lysanne, you can answer them in the chat.
Yes.
Great, super. In the meantime, we go to our next and final speakers. Luuk Fleskens, he is an associate professor at Wageningen University and Research. He has a presentation about his SDGP project related to impact assessment modeling of land interventions in Madagascar. His presentation is in collaboration with Hermano Guiducci, and he's a master student in international land and water management. Luuk, the floor is yours.
Yes, thanks a lot, Maxime, and thanks for everyone for attending. Yeah, the presentation will be on the Tsara project, looking at scenario modeling to consider the impact assessment of different land management interventions through a land simulation platform. I will be talking a bit in general about this land simulation platform, and then Hermano will be going to the project detail and how general information and local information can be brought together in looking at scaling of interventions. Next slide. So briefly, our Tsara project is working in the southern central highlands of Madagascar with 2 companies, one focused on rice marketing and the other one on artemisia. And artemisia is a crop that can be produced in tropical environments, and it can be used to produce an antimalarial drug. The idea of joining these 2 companies is that by combining 2 cycles, so a wet season cycle for rice and a dry season cycle for artemisia, farmers can have an income at 2 points in time, and that together with improving agroecological practices, this might then lead to improved income. We also pay attention to landscape restoration in the project, and we are interested in understanding the upscaling potential of improved agricultural practices. And for that, we establish a monitoring and evaluation framework coupled to a decision support tool. And that is the LandSim platform that I'll be discussing, that we developed earlier in a World Bank project in Madagascar. And it's a national level platform to look at the impact assessment of various types of interventions. Next slide. Just to give you a bit of a picture of the environment, we have valley bottoms where rice is cultivated going up into the mountains, and then the overall landscape is quite degraded as well. The question is, with its growing population and a changing climate, how does this system work? Next slide. In our platform, we have coupled models in which we look at grid cells of about 300 by 300 meters for the whole of Madagascar. What changes could occur and how they would affect different outcomes. So the land use, the forested area, erosion, but also livelihood impacts. And using this platform, because we couple different types of models, we can really look at different effects. So, for example, a socioeconomic change, a growing population will lead to more population, also migration, and how that affects the land use can be considered. Of course, with planning, important things are like where do you actually implement improved practices? Where do you protect environment, etc. And then also policy instruments can directly influence or incentivize farmers to change through price mechanisms or support. And then climate change directly also has an impact on hydrology, on vegetation and soils. And this can all be covered in different ways in the platform. Next slide. So what we look at is the dynamic suitability for different types of cultivation. So here an example is for rice. So you would lowland rice you would grow in valley bottoms, but also at a bit larger altitudes. On irrigated areas, it cannot be too slopey, and with different types of chemical soil fertility and with water availability. This then, if you take all of this into account, you have a different suitability, which is depicted to the right, where, yeah, if a good yield is possible in a few pixels, then you see that in many cases, yeah, the conditions are suboptimal. Next slide. Of course, in our scenarios, one important thing is to really think of a doubling of the population basically in 30 years. So that really puts a lot of pressure on the resources and leads to deforestation and land degradation issues. Next slide. In the platform, we can also look at different climate futures, so climate change projections. Here we take two different scenarios, a relatively dry one and a relatively wet one. And then if you look at the trends, you see it has some influence, but not as big as like a doubling of the population. So you see a 7% increase in overall precipitation, for example, in a wet scenario, and a 1.3 degree higher temperature on average for the dry scenario. But that's, I think what is even more important is to see what are the extremes in these scenarios. So the overall trend can be relatively smooth, but yeah, the fluctuations might really make a difference. Next slide. So applying this platform under a kind of business as usual scenario, you see, of course, by a growing population, a big expansion of arable land and also other systems. Next slide. And here you see that over time, if we look at the erosion patterns, it also changes due to the distribution of rainfall and extreme events. So, for example, in 2035, there was a lot of extreme rains in the southeast, and that you really see in the simulations. And then erosion would lead to land degradation generally, but also it deteriorates the conditions, meaning that either you need a lot of investment to maintain productivity, but also farmers might then at some point abandon the land and look for new land to cultivate. Next slide. So we use this platform to simulate an agricultural intensification scenario where we intensify rice production through interventions in soil fertility management, manure application, as well as fertilizers, and further development of irrigation, combined with a development focus where value chains make sure that there's a better connection to the market of farmers, cheaper input availability, and a better access physically, because the road network in Madagascar is often very poor, and rehabilitating roads will help here. And then the assumption is also that if farmers get a better income, they can attribute or reinvest some of their income in an improving system. So let's see some of the results that come out of this. Next slide. you see how the land use is gradually changing. You don't see a lot of change, but if you jump back from 2050 to the beginning of the simulation, then you see that over time there's really a big change in terms of mostly lowland rice production, which is the most important system. Next slide. So what we see with this intervention is that the yields due to the intervention really improve, but because of the degradation and also because the growing population encroaches on less suitable land, overall there's still a decrease in the yield levels. Next slide. The agricultural profitability is a lot better for most farmers, but also not equally everywhere. So that is an important consideration due to the connection to the markets and yeah, the locations play a role here. This helps for better livelihoods of different types of farmers, but yeah, the effects are not similar everywhere. Next slide. And we can also see that different types of households really improve on their caloric interventions, either due to improved production or because they can earn cash and then buy food. So this really shows that there's a good effect of this. Next slide. So with this scenario, we can really see that there are increases of productivity, that it helps households to get better food income. But it also, yeah, means that the land use changes are still going on and there's quite some pressure on the natural areas that maintains. So we are adapting this platform now to look at the regional context, and Hermano gives some first ideas about that.
Yeah, next slide, please. Good morning, everyone. I'll shortly present some of the practical insights from my research in Madagascar, where my main goal was to evaluate the upscaling potential of the land management scenarios as proposed by Project Tsara. Next. So, Luuk has been showing the potential of the Laurel simulation platform on a national level, while we will zoom in now as I focused on a case study approach in the central highlands of the country. The SETA project, again, very briefly, aims to address several of Madagascar's agricultural challenges by promoting an annual crop rotation targeting smallholder farmers. A particular challenge in the region, which is shared by other similar case studies, is the low quality of field-derived soil data, which is especially problematic in this case with maps about soil type and soil parameters. Next. Agricultural development projects such as Tsara require a robust evaluation of available land to achieve spatially targeted interventions. But there are no clear protocols for the selection of new areas or knowledge on locally adapted criteria. I wanted to address a research gap in the comparison between conventional land suitability studies with participatory approaches within a single case study. Next. To do so, I performed a parallel expert and participatory-based land suitability mapping, revising the FO's framework for land evaluation. The two methods are distinguished by the knowledge sources these processes are based upon. So on the one hand, we have the expert assessment, which incorporates inputs from local agronomists, literature, and crop technicians. On the other hand, you have participatory assessments, which emphasize the process of smallholder engagement. Their empirical knowledge and their perception of land qualities shapes the GIS models. Criteria were both weighted with an analytical hierarchy process and with direct weighing by farmers through small focus groups.
1 minute.
Next. Well, I have to hurry. So the participatory process granted as main result that farmers correlate field qualities to specific field types in the landscape. So a combination of NDVI, slope, and nested TPI was able to find those fields. Next. My goal was to distinguish practical feasibility from theoretic agronomic potential. To do that, I applied logistical constraints on cropping systems, considering distance from population centers and access to water in the dry season. Next. So the result. Foremost, the results were able to inform the project partners on clusters of highly suitable spots on a 30-meter resolution. Second, by overlaying the two suitability maps, so the participatory one and the expert one, you can find places where farmers might overlook potential, places where farmers recognize suitability despite lower potential, but most importantly, fields for optimal implementation. Those are the low-hanging fruits. In conclusion, the study highlights the use of farmer empirical knowledge to overcome challenges in data-scarce environments, and the combination of expert and participatory knowledge results into more realistic and locally adapted evaluation of land management scenarios. Luuk, if you want the last slide.
Yeah, it's still on the... Yeah, okay. Yeah, you can run through the simulation. What I think is important in the context of this learning approach that Veerle also already introduced is that we, of course, we don't really know what the outcomes will be in an uncertain future. And a process by which you use scenarios can help, first of all, see where the practices that you want to implement are possible. And that gives you a bit of an idea and information for stakeholders to discuss what is possible to manage. But then also to already have a kind of look forward into possible results, for example, in terms of the sales of products that we can monitor within the project, but more importantly, the outcomes of, are livelihoods really improving or not? And of course, you cannot really monitor this on the go if the results are long term, but with scenarios, you can bring forward that discussion a bit and see what the potential is. Thank you.
Thank you very much, Luuk. Thank you for your attention. Let me see. James, you have a question from Ghana. Could you speak up and pose your question to Luuk? Are you there? Otherwise, we go to Irene from Indonesia.
Yes, good morning. Good morning. I'm online. This is James from Ghana.
Welcome.
Thank you, sir.
So,
Yes,
what's your question?
I was asking the impact of the climate change on cocoa production in Ghana is so severe. I was in one of the cocoa farms yesterday. I have the videos I want to share. The hectares, thousands of hectares of the cocoa farms are dying. So I'm asking this great platform, what can immediately be done to remedy this situation? Ghana is going to lose its position as the second largest producer of cocoa in the world because of the trend, because of what is currently happening. And I just want to ask if there will be any support, if there will be any help to remedy this situation. Thank you very much.
Yeah, that's of course a challenging question. So if climate change is leading to real impact, I think the solutions should come from building more resilient systems. So either within the cocoa system or within the landscape to support, for example, better water availability or more shade or all kinds of interventions. And then if you have an idea how these interventions impact on the system, then you could use models to simulate the future. That is, of course, depending on the specific challenges that you face, you might be able to use an existing model. It might also be that you need to combine different elements, and sometimes not just use scientific models, but maybe also participatory approaches where you combine local insights and scientific insights. But it's a challenging situation.
Yes, thank you, Luuk. It's indeed challenging. So in the meanwhile, we have a small poll to evaluate this webinar. I kindly invite you to fill in the poll. It's just a few questions and then click on submit. I will give you, let's say, 1 minute and then we close the poll again. And there's another question. So in the meantime, we can go to that question from Irene from Indonesia. Could you speak up and pose your question to Luuk or Emmanuel?
Sure. Thank you, Maxim. Actually, my question is not only for Luuk, but also for the other presenter. Do you also involve your beneficiaries for the sustainability? Because mostly after we finish the project, the monitoring also finish. And also if there's another way on how we create the monitoring tools as simple as it is, because usually our beneficiaries, sometimes they didn't have a high-tech technology. Thank you.
Yes, thank you. I think in our case, with our Melons work, what we try to do is also see from the local farmers' perspective what they think are the suitable conditions for the innovations. And then, of course, if we over the course of the project see that it works and people feel it works, then they can also take that learning forward. But I guess looking into the future is also looking at conditions that might be a surprise for everybody. So then it's good to understand from both scientific and local sides what is needed.
Yeah, maybe Irene can just add 20 seconds something that in the case of Zara, the interesting thing is that the collaboration is with through outgrower schemes. So there are 2 local companies that are engaged on the front line of monitoring what those farmers are doing. So by having outgrower schemes in this very specific case of the project, you'll have like 2 companies that will remain on the field, that are on the field long after the project has gone, in theory.
Thank you. Is there another presenter that wants to add to this?
Yes, maybe I can add something. I'm also working on a program called Reversing the Flow, and I see some of the people we work with are also in the call. So Hosea from MITP, where it's a locally led program. So there the community is very much involved, also with the monitoring. Can't really say about after the program because we're still fully implementing, but that is we are working with that. So, and I saw also some from IIED is in the call, so maybe they can also say a little bit about it if they want to in the chat.
All right, super. If there's no, is there another speaker that wants to add on sustainability of monitoring and evaluation?
Hi, Maxim.
Yes.
Thank you. My name is Osea, and I'm happy
Welcome.
to see a lot what is happening. We are implementing reversing the flow. Lambert has said it well. From this monitoring and evaluation, the key part is how do communities take lead and take on monitoring and giving it more from a community perspective. Something we'll be interested to learn on, and also it can build further to the scientific part of its work. Thank you.
Thank you, Hosea. Yes, welcome. So we should round off. It's 1 minute to 12. If there are other questions, then please send them to us and we will try to answer them. Thank you for your attention. The slides and the recording will be shared with you afterwards. And the next and final webinar of this series will be on examples of nature-based solutions for agriculture and forestry on the 19th of June. So thank you very much for your participation and see you the next time. Bye.
Thank you. Goodbye.
Thank you very much.
Thank you.
Thank you all. Bye-bye.
Yeah. Thank you very much.
Bye.
Thank you. Goodbye.
Bye-bye.